To find the E, phi, pi triangle, we begin with the base 1 unit square as a quadrant and a base 2 total area 4 square. As we close in on the base 1 unit square, we should examine its square root of 2 diagonal and how this same line segment may form the radius of a circle that then inscribes the whole 4 square. Again, note that the ratio of the line segment square root of 2 minus 1 to the line segment 1 is proportionate to the ratio of the line segment 1 to the line segment square root of 2. This ratio approximates, but is not exactly equal to, phi. Next, let's zoom in still further to the relationship of the square root of 2 diagonal acting as a radius and the square root of 5 diagonal spanning across the 1 to 2 golden rectangle from 1 to the opposite corner. Here we see the base 1 unit square, the 1 to 2 golden ratio rectangle, the square root of 5 diagonal of such a rectangle, and the square root of 2 diagonal of a unit square used as a radius for a circle. As we are about to see, the square root of 2, the square root of 3, and the square root of 5 are basic measurements in a Vesica-Pisces arrangement. The Vesica-Pisces, or fish vessel, in addition to being the geometric origin for the symbolic ichthys, or fish logo, used by early Christians some 2,000 years ago, is a storehouse of several anciently understood sacred geometric ratios. When two equal-sized circles are conjoined to overlap one another exactly 1/2 each, such that the midpoint of one circle is a point on the circumference of the other, then the standard Vesica-Pisces graphic depiction is formed. There are variants wherein the twin circles overlap either more or less than halfway, but these are irrelevant to a discussion of the measures that occur in the particular Vesica-Pisces wherein the twin circles overlap only and exactly halfway. What we find when we construct such a halfway overlapped twin circle Vesica-Pisces motif is that when the radius of these circles are given as base 1, such that each is a standard unit circle, then we find the square root of 2 also as a diagonal of the twin squares drawn to cover the overlapping circle's area, the square root of 5 as a diagonal connecting one corner of these twin squares to the opposite corner, and, lastly, the square root of 3 as the vertical line segment connecting one archway of the vesica to the opposite. Now, when the same motif is depicted again in sequential ratios to those of the 1 to 2 rectangular covering space, only nonetheless at a slightly different size scale, we may measure a particularly miraculous triangle from within this shape as well. When the diameter of each of the twin halfway overlapped circles in the vesica model is taken as equaling the transcendental number sum pi, then diagonals connecting the ends of either circle's diameter to the point at the apex of the archway of their shared space will measure phi for the shorter leg and e for the longer. Now, this triangle is indisputable, obvious, and elegant, yet remains mysterious in many ways. That a triangle with leg lengths equal to phi and e and a hypotenuse length equal to pi exists is not necessarily itself surprising, considering that even though each of these may be an irrational number and two of them transcendental numbers, meaning they cannot be derived evenly from any algebraic equation, they can still be represented as continuously fractional integer sums and thus treated as numerical variables in ordinary polynomial equations. In short, pi equals approximately 3.14, phi equals approximately 1.618, and e equals approximately 2.71828. Thus, relating these sums to one another trigonometrically is not impossible, and even occurs naturally in the context of the Vesica-Pisces motif. The E, phi, pi triangle is another unique extraction from the sacred geometrical Vesica-Pisces. Although it is very closely proximal to being a right triangle, the E, phi, pi triangle is not a proper right triangle, because its closest proximal corner is 89.1 degrees and not 90 degrees as in a proper right triangle. The corner between the shorter phi leg and the longer E leg is 89.1 degrees. The angle between the shorter phi leg and the pi hypotenuse is 59.9 degrees exactly, and that between the longer E leg and the pi hypotenuse is exactly 31 degrees. These exact measurements also place the E, phi, pi triangle as being more like a 1, 2, square root of 3 right triangle with interior angles of 30, 60, 90 degrees, rather than the traditional 3, 4, 5 Pythagorean triple, which notably has interior angles of approximately 36, 54, 90 degrees.